Okay, so after condemning the Philips, which you will probably see in another video, we have this. This TV is a Cossor 938. There's no branding on the front. Cossor 938 from 1954, same year as this, but this one has a band 3 tuner, which meant that you could watch ITV on it. Oh, that does require a lot of force to, yeah, and because there's channel numbering in the opposite direction behind it, see, 1, 2, you can see that on there, look, these knobs, these dials are not original. These have been taken from something else, but this is what it was like when I got it. Let's turn this thing round, which is something I can actually do with this, unlike the Philips. And it's in even worse condition at the back. What have I just dropped down there? Anyway, yep, it's in worse condition at the back. This is the focus control. You turn it, it's magnetic focus. I think that rats or mice may have made a nest in here at some point, which is why I am only doing a resurrection on this. I am not restoring this, and I'm not bringing it into the house. Because yeah, these are carpet fibres, usually from where rodents have just bitten off carpet fibres and then used them for making nests. Yeah, line output stage with EY51 EHT rectifier. At least in this one, unlike the Philips, at least in this one, that looks replaceable, or at least semi-replaceable. Another thing I noticed was that is loose. That is that's PY81, that's the boost diode valve, and I think when you look at it, that I don't believe that valve socket is original either. Right, one thing that you will probably notice now, and that will likely make this a pain in the arse to service, apart from dogs barking, is, yeah, see, let the dog tell you. Translated, that means, oh, the dog speaks some more. Anyway, translated, all this means is that it's a double-decker chassis, which is going to be a bit of a pain in the arse for quick servicing, but yeah. Amp fuses. At least that one's 1 amp. I can't see what this one says. Octal socket or something to connect it below. That is rusty. That's not going to come out with one hand. So yeah, line output stage and line output transformer. So yeah, Cossor seem to have done the same or similar thing to what Philips did with this, in that they had power supply and time bases, so frame and line time bases and frame and line output on one chassis, and then sound, vision and signal on another. At least that's the impression I got. That's the impression I get from just looking at this at first. At the time of recording, I have not looked at the service manual. I will need to download that. And this thing is absolutely loaded. Let me move my light out of the way. Absolutely loaded with wax paper capacitors. Chock full of them there, on which I think is the time base chassis, and on here, which to me it looks like the signals chassis. That's screened, which probably tells me that that is the IF, or tells me that that is probably the IF stage. Yeah, and there's a fair few electrolytics there as well, all ready to go short circuit. Lovely. Lovely, lovely, lovely. I think I've found the mains filter capacitor already without even looking at the service manual. There it is. This guy here. That's the chap. And the reason why I came to this conclusion is because one side of it seems to be connected to ground, and the other side is connected to the on and off switch. That on and off switch doesn't sound or feel right either. I just thought I would, because Cossor are probably not going to be a brand, or company rather, that many people will remember. There will be some, but many won't. So this is from Wonkipedia. AC Cossor was a British electronics company founded in 1859. The company's products included valves, radios, televisions and military electronics. Well, we know that they made valves because there's a few Cossor branded valves in here. I saw them earlier. In fact, there's one. So they made their own valves, not relying on Mullard or Mazda. And no, it's not the Mazda that you're thinking of. It's not the Japanese car manufacturer. It's a different Mazda. Anyway, the story of AC Cossor began in 1859 when they were manufacture scientific glassware. His eldest son, also called Alfred Charles Cossor, joined the company in 1875, and it was he who founded the electronics company Wright. The company's expertise in a manufacturer of electrical glassware, which explains why they made valves. Led the company to diversify into electronics. Hey, what? Hang on. This phone is still not used to my... Now, company timeline. When did they make the first TV? 1924, Cossor introduces the first British valves to incorporate an oxide-coated filament. Started making radios in thought they started making them in 1927. After World War I, the company produces its first radio sets in kit form. 1930. First British RF pentode valve made by Cossor. 1932. They make the first oscilloscope. 1936, so they were there right at the start of public television in the UK. Company sells its first television receiver. So why have we not heard of them? Well, it said up here that they were sold to Raytheon in 1961, but I think they stopped making televisions before then. Yeah. Cossor sells its domestic electronics business to Philips. Okay, right, so it's distantly related to that. Yep. So yeah, the company ended in 1961. Okay, it's not that one. It is this one here, which is capacitor 77, which, according to this page, is that one there, which translates to this guy here. So what does capacitor 59 then do? That's the one there, capacitor 59. What does that do? There's capacitor 60, 55, and 87, 61. It's for the volume that connects up to there and then goes to 0.5. Right, and the other end of it connects to the volume control, which is the sound of the toilet flushing, which is this control here. It's really, really nice, isn't it, when they don't have anything on either mains cable to denote which is live and which is neutral. Thank you, Cossor. So what we're going to do then is, first of all, we're going to pray that that's not being messed around with by wiring. That, ooh, come on, focus. Right, that soldering, is that original? I suppose it might be. Let me just turn the... I was thinking that the camera would automatically readjust its brightness, because I'm thinking that brightness of the bulb shining off that is making that solder look newer than it really is. I've just noticed something else about the history of this TV. It's a Regal tube. Everything about this set is just telling me that this was used and used and used, that this is a very high hour set. That's the impression I'm getting from this. The rats who made this, rats, mice or whatever, that made this mess with carpeting, I now don't think that they've actually been nesting in here. See, there's a bit up there. I don't think that they've been nesting in here at all, because otherwise you'd get rat feces or mice feces. Why do we keep on saying rat? Unless I've got a subliminal fear of them. Which, as far as I know, I don't. Let me just grab it. I've got a plug added on the end. I'm about to... There's that mains filter. Where have you gone? You were here. Ah, there you are. I'm about to cut one lead off that so that it's disconnected. Right, and then we'll power it up on the lamp limiter and the variac. Okay, so I've just switched it on for the first time in many years. I don't know if you can hear it, but from somewhere it's making this noise. At first I thought it was something to do with valve heaters or something. That maybe we're hearing arcing inside a valve or something like that, but it does it immediately from when I switch on. It's not as if there's a valve not as if it gives a chance for the valves to heat up. And it seems to be coming from the top deck. Doesn't seem to be from the tuner. And I've got it on, being wired through the lamp, but there's no lighting on the lamp, and it's only drawing about 6 watts. So we've got a short here somewhere, I think. Definitely got a short circuit. Right, I've just decided, let's just go for it. Let's just power it up without any lamp limiter. There's something that's drawing current. So much current that even the lamp limiter can't light, and that only shows about, what, 5 or 6 watts. Even with the lamp limiter, that should show about 60, 70, 80, something like that. So yeah, I think we're going to have to just switch it on and just see what shorts. The reason why I am going to take some precautions, why I've got this over here and why I'm stood over here and the back of the set is pointing that way is because with the way that the valves were, or that the heater chain, the valves weren't lighting up even though they were obviously conducting. There was some power, there was some power draw. I don't think that the electrolytic capacitors will have reformed. So I would say in rare occasions capacitors like that can go bang pretty much straight away. Right. However, that's not going to cause any issues or any safety to me or anyone else in the house or anything like that, because that is fused twice over. There are two fuses there. We are fused here, and we've not got the current limiting. We're just going to switch it over. Let me just do that. But we are fused in the plug, in the power monitor, within the variac, and also within the isolator, and also within the, where is it, there we are, that's got surge protection in it as well. So let's go ahead, let's do it. Right, so I'm going to keep on filming this. If it expires, that is fantastic, because the entertainment value of that is worth more than the set is. So, right, here we go. Full power. And of course it would help if I switched that on. You just point that up there. It's making the same noise. And it's still only drawing about 6 watts. Okay, I've just realised I've been a bit of an idiot. I've not switched it on to full power. Duh! Right. There's still no difference, dare I? Still no difference. And that's at 6.2 watts still. Hello, and welcome back to What Shit Is Sticky Talking Now? The shit that Sticky is talking now is, I've worked out that that sort of noise that, I'm not sure if you could hear it, but it was kind of a faint power rustling noise, like a very small tinkling. That's the best I can describe it, but it is coming from these two. Neither of them are faulty because I've swapped both over with each other. Swapped one with that, that with one, made no difference. Then swapped that one. Basically I've just swapped them around, right, so that, yeah, that's one of the original valves, and there's no difference. It's still making that noise. To prove my theory that I thought it was the heater chain I could hear. I pulled out that valve back there and switched on, which should break the chain and thus make no noise if my theory was correct, and it wasn't correct. So that valve is not milky, it's just the light shining on it. So the heater chain is broken, and looking at this, I thought it would be prudent to check here first of all, because it didn't sit right, and I thought that it was just where it just didn't seat in. So I've tried it, wiggled it around, switched on, wiggled it, switched on, each time no difference. Then I looked inside the valve pins. Let me just get something to point with. That'll do, I think. Just move the valve out of the way. So we got pin 1. It's a PY81. The heater pins are on pins 4 and 5. Pin 1, pin 2, pin 3, pin 4. Look, there's no socket pin in there. Pin 5, 6, 7, 8, 9. So someone's been in here, tried to fix it by replacing the socket, and I think they've cocked things up. Okay, a little bit of time this evening, and tonight I am going to try and remove this chassis. So that I can sort out this heater chain, because someone's not done that. I will need to trace this wire, because I'm not confident that they have wired that up correctly either. But yeah, there's plenty of signs that this has had a long life. Some of the ones I showed you in yesterday's clips, that of course I'm going to publish in the same video. But also another sign, that potentiometer, don't know what it controls, but that potentiometer is not original. Yeah, that's not original. That's a 1960s or 1970s one. Let me... There's the back of it there. Might be younger, but it's still got the same amount of rust as the rest of this. Sticky tape and crust. Ugh. Disgusting set. Disgusting. Another sign of a repair. To get this out, it's a double decker. This half slides out, and then that allows you to access this half, which then also slides out. So it kind of slides out in two steps. That one, and then so the lower deck slides out, and then the upper deck slides out, but only half as far as the lower deck does. So it's kind of stepped when you've got them both out. Anyway, that came out of there. Phillips screwdriver, a Phillips screw end I mean. The other end looks like it's the original, a flathead screw, or yeah, whatever. This has definitely not been looked after by someone who appreciated it. Right, that is actually not as bad a design as I first thought it would be. See, at first I was dreading, oh no, it's a double-deck chassis. These are going to be, top deck components are going to be a pain in the arse to get to. But no. I then noticed that there were some screws on the other day. Okay, realised that, okay, this is not as difficult as it first appears. The top deck slides out. Right, but I was first thinking that there were going to be loads of wires, but actually no, apart from this, which plugs into a socket down there, plugs onto a pin down there, I mean. There's enough slack in the cables to have it mostly wired up while you're still working on it. And I guess it's a good thing that this is actually so serviceable, because yeah, all of these capacitors will be leaky. Wax paper, all of them. And even if they won't be leaky at first switch on, they will soon be leaky afterwards. What capacitors are there up here in the tuner? I wish that this camera had a light on. It's otherwise really fine, but there's no flashlight on the front of this thing. No. Oh, there's another Americanism. Not a flashlight, torch. Torch. I could swear I saw a capacitor up in here the other day. I see it right there. See that black thing with the yellow writing on? The camera's struggling to focus on it, but that thing there, that is going to be a pain in the arse to replace, because that is a capacitor that's made by Hunt's, and there's a reason why the television repair industry, even in the 50s, the 60s and the 70s, used a very rude rhyming word for Hunt's to describe the company that made them. Those go open circuit at the drop of a hat. It's universal law of electronics, an unwritten universal law of electronics, that any Hunt's decoupler capacitor, a decoupler capacitor, that's black or sometimes brown, universal law of electronics, an unwritten one, is that will be open circuit. And it's in that. Well, I was wrong about that, wasn't I? Of course, the valve pins are counted from clockwise, but from below. Just get something to point with. Right, so 1, 2, 3, 4, 5. Those two are the valve pins. 6, 7, 8, 9. So but that said, that should actually, that's just me assuming the worst, because I've been a bit of an idiot, right, with thinking that the thing was wired up incorrectly, because I've seen all sorts of bodged repairs on TVs over the years. Anyway, but yeah, we still have to diagnose where in all this, or I'm dreading it, maybe even in the tube itself, the open circuit for the valve heaters is. And doing it from down here gives me a good indication of where the break is. Okay, I've just taken the tube socket off to clean this, because first of all to clean it, but also first of all to check the heater continuity, because my thought was that if the heater in the tube is dead, because it's the same kind of tube, scratch my arm, the same kind of tube as that uses, and I know from a previous video, and you'll find out at some point in the future, I don't know, I've not decided yet, that the tube in that is quite good. Right. Turns out the heater pins do have continuity. They just needed a lot of cleaning, But I realised after I'd taken the tube socket off, that's the reason we have no heater continuity. Both of the wires that connect to one of the heater pins, which on this kind of socket is this pin on this, this kind of tube socket, whatever, this pin and this pin are both so corroded the wires have come off, and I barely even touched it. In fact, when I first saw it come off, that was only that was disconnected, and this was still connected, and I've just lightly touched it and they both come off. Also, this is coming off as well. I'm going to try and repair that, but I may have to find a spare tube socket somewhere in there, just to get some life into this, or maybe just solder the entire thing, including capacitor, directly onto the tube base. At least that is alright. That's the most important thing. That and the line output transformer. If that, at least we've got heater continuity. If that has got good emission, and if that is still active, then we are pretty much good to go. This thing just keeps on getting better. This might have been on the previous footage. Don't think I can show this very effectively with one hand, but look, that hasn't even been soldered on, that's just been wrapped around there. What kind of... I think at least that partly vindicates my suspicion that had been bodged, when it has, when I've told you 1,000 times now that it hasn't. I told you 1,001 times before that it was, but anyway. What an absolute crapshoot of a set. Good design, but whoever repaired this over the years, my God. Even I'd be considered a professional compared to this. Compared to some of the work that I've found so far in this, God knows what else is. God knows what else is what else is lurking in there. Okay, who says I don't like having a challenge? Right, I'm even considering reconsidering my decision to stop doing this after I've discovered I've got a few EY51 valves. Right, probably just melt the wax, replace the valve, and then just leave it without any wax. Anyway, so yeah, I've resoldered all of these. I've done the best I can, but yeah. Now, apart from that, because that snapped and I just could not get solder to join it together. So what I've discovered, if I just pull that out of there for a moment, plug this on here. So tricky doing this one-handed. Yep, there we are. Then I can poke that down there into the tube, and it should, into the tube pin, and that should, and I repeat, should make contact. Now this capacitor is another sign of a repair. I originally thought that this was one of those wax paper capacitors, but it is not. That, I can't remember the make, but I've seen these capacitors on 60s and 70s TVs, I think. So this thing was used into the 70s, probably into the probably even into the early 80s, if that's new old stock. And that resistor does not look original either. Again, I've seen those on 60s and 70s things, so this thing had a long life. Right, I'm going to repopulate that valve socket. I've also had to unplug a few wires from this bottom from this connecting the top chassis to the bottom. So reconnect that up. Drive away in the car if you can hear that outside. Yeah, reconnect that up and switch on. There we are. So we at last have heater continuity through this thing. Now that is that staying as bright as it was? Oh no, I think it's getting a little bit dimmer. There's another repair. That actually looks like the same kind of capacitor as that. So either that was repaired at the same time, or maybe they are factory original, but I've never seen those kind of capacitor this early. Ah, maybe they are original. Look, there's another one. They don't look like wax paper capacitors. Wax paper, oh, wax paper ones usually have slightly more rounded ends to them, like the TCC ones, but I've never seen wax capacitors with like a straight edge to it. I've always seen the slightly more rounded ones. If I switch that over, what wattage are we getting? 62.5. And it's yeah, it's about stable. 62.4, shall we say? Which is, yeah, around about what I would expect. But yeah, I can't find in this. I can't find an example of the kind of wax capacitor I meant. But yeah, see how the camera goes out of focus when I zoom in too far. See how that corner of that capacitor is pretty much a right angle. Usually a wax one has a slightly more curved end to it, probably not as much as I thought, but there's a slight curve to the edge on most wax capacitors. I've never seen ones this early, straight-edged ones. I mean, are they even wax? I'm just assuming that they are. Just a quick one today, guys. It's 27th of April 2023. First of all, I should point out that when I was first switching this thing on, and there was no light down here, I was of course a bit of an idiot. If a valve was, I think I hypothesised at some point that one of the valves could be short circuit. Could have a short circuit heater or short circuit to cathode or something, I don't know, I can't remember. Anyway, of course, if the valve was short circuit, it's not going to draw so much current that won't light, or if it was, then the valve itself would light up like a Christmas tree, wouldn't it? Duh! I don't know why I'm making so many mistakes. I mean, I've done this on and off for 10 years. That was my last restoration. But that was about a year ago, and up until about a week ago when I started tackling that, when I decided, right, I'm going to make this, I've got so many sets, I've got to restore them and get rid of them, because that was my original intention with them. Yeah, before a week ago when I started doing that, it used to be usual that I would do like one or two a year. And for someone who's intending to, for who this hobby is still fairly new, I was never in the TV repair trade. I'm way too young for that. I'm only 32. This, if you keep on starting and stopping and starting and stopping, then eventually you're going to lose, you're going to start to forget some of the basic fundamentals. Yeah, and I think that, combined with my medication for my anxiety disorder, it's citalopram, it does have an effect on long-term memory. I think both of those are having both of them are sort of working together to make me quite forgetful and quite disorganised, disorientated, whatever. Right, anyway, fundamentals. And I need to start diagnosing from fundamentals rather than coming up with elaborate explanations and unlikely explanations, like flushing the toilet, like heater cathode shorts or whatever, I don't know. But yeah, I need to stop coming up with, when diagnosing, I need to just stop jumping to conclusions and coming up with that. That's a really bad habit. That's a really, really bad habit. If anyone is learning or wanting to diagnose, or learning to want to diagnose, I beg your pardon, how to fix TVs and other sorts of things, just bear in mind the toilet is still flushing, by the way. Just bear in mind, though, that I'm not an expert. I was not in the TV repair trade, as I've already said. I just do this, first of all, to document my own progress, my own learning, and secondly, just for entertainment value. People like to see old shit like this brought back to working order. Anyway, a couple of other things I wanted to note. It's definitely yet more evidence it's had a hard life. These, I can assure you, I've not scratched those in. I never would, even if I did. The writing is still too neat for my writing. And also, the aerial socket is bust. Not too much to worry about though, I can replace that. But yeah, so it has been on the lamp limiter for just over an hour now. It's about 5 to 10 in the evening. I'm just going to stop recording for a moment just to turn this over and make sure that the back is facing the wall. In case anything decides to expire or explode, it can do so against the wall or on the workbench, but not against me. Right, so yeah. Another day, another celebrity death. Jerry, 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 Jerry. Don't think I can honestly say though that this thing ever displayed anything like his talk shows. I think the closest thing that this would have ever, closest program that this would ever have shown to a program where people air their, or people discuss their private lives or something, might have been House Party, which was on ITV in the 60s and 70s, but even then, that was an absolute, never mind a world away, that was pretty much an entire universe away from that. House Party, very middle class women with rich husbands, Tory women who never had to, I would say, well, never had to do any paid work, of course. Housewife, being a housewife is very hard work for, yeah, no pay. Right, here we go. That is switched on, because I've not even touched that since it was on its side and the light was lit. Switch that to full power. Here we go. We have a pop of sound out of there. Ooh. Ooh. It's really, really flaky volume control. But in between sounding like a crackly telephone line, we have the sound of a rumble. That's main tom. And it's probably just because it's turned up. Yeah, it's just because it's turned up to maximum volume. Because when I turn it down there, we'll still get the crackling landline. Crackling, sound of a crackling landline, but nothing else. So, just because it's on full volume. And that is it. I wonder if And in fact, no, we would hear line whistle, wouldn't we? Still, I was just wondering if the lack of anything on the screen was down to this valve here being loose, but the line oscillator, of course, has to start, and it is not doing anything. Not a hint of line oscillation. Let's not a hint of any line oscillation. Come on. Oh yeah, I smell it. I smell it. Something's giving way. I thought it was a capacitor that was getting hot. I mean, I could smell something burning. I thought it was going to be that guy there, or this guy just under here. But no. Watch this. I'm switching on to full mains now. That guy is... oh yeah. 6AL5. Made by Bryma of the BVA, the British Valve Association. Yeah, I'm just starting my computer up because I want to see if I've got any of these in my valve pile. I have a spreadsheet for valves, but spare valves I've got right. 6AL5, that's an American, this is something that confuses me a little bit. That's an American type of part number, of valve number. But it was made here in England. If it was made in England, why not just use the European part numbering scheme, part numbering system? It sounds like it's either hollow or there's something inside which is shorting, which makes sense given how bright it was. Okay, this site, I'm never actually sure what the name of this site is. I know what the URL is, but hang on, Valve Museum, is it? Yeah, oh, yeah, the Valve Museum. I've never noticed that before. Never noticed that. Anyway, I think I have 62 D77 and EB91 in stock. So yeah, sensibly equivalent to, so not an exact replacement, but sensibly equivalent. So these valves are similar and may work. There are two 6AL5s in this thing, the vision detector and sound automatic gain control clamping valve. I think what that does is it makes because it's an automatic gain control, how can I explain this? This is where the signal, the sound is in this case is at a preset level, and then the volume boosts it from that. Clamping, that means it's, if the sound incoming is varying, then that tries to clamp it to a certain level. Right? so it's got a solid basis for increasing volume. Right, and then the other one is the sound detector and sound interference limiter. So it filters out any interference. It must be a diode then. It's got to be a diode or double diode. Right, so where are we? What I want to do is I want to check if that is the first valve in the heater chain. So first of all, I will need, there's the top view. I don't want the top view, I want the bottom view. Well, not the bottom view, but a top view of the bottom half. Right, valve 4, I think is it. Yep. So yeah, because this valve here is that one there, valve 5, so that one's valve 4. Right, and now what I want to know is where that is in the heater chain. Because I was just concerned if it was the first one, then that one will get, then when it's been switched on, then that one is a little more likely to receive any current. But no, valve 4 is right in the middle of the valve chain. That could also, capacitor 65 could also be short circuit as well. If that is the case, we will need to find out where valve 9 is. Valve 9 is that one there. Right, but I'm going to try it with a different valve first, if I can, if I've got any. If I haven't, then I will see what the capacitor is like. Right, so here is what I've done. I've swapped these two valves around. This one was here, that one was there. If the valve is faulty, then this one will light up like a Christmas tree, because this one was the one that was there before, as I've just said. So, if the valve is faulty, this one will now light up very bright. If it's the capacitor that's faulty, that one will light up very bright. Right then, let's power up again. Yep, the valve is faulty. I found this. It's EB, then what looks like a rubbed off 9, and I can't see the last digit at all. So it looks like it was some kind of printing mistake at the factory. But anyway, that, the insides look very much like an EB91. EB91 installed. Let's give this a go. That's more like it. Yeah, that valve doesn't look as though it's all that well used. I mean, obviously there's some dirt on it, but usually after many years use you start to see internal brown or black staining on the glass. I know that there's some kind of staining at the top, but that's the getter, mercury getter inside, mercury vapor getter. So that valve didn't last long at all. Maybe that's what's condemned the set. Right. Maybe it broke down with the original 6AL5 that was there. It was taken to the repair shop. That put in. Right, and then a few weeks later that failed. So we've already tested it in the back. We know it doesn't light up very bright, or doesn't light up much brighter than it should do. So let's switch that on. Right, and we'll give it, what, 2 minutes for anything else. The reason why I've decided to do it again, to get the TV again facing me, the back facing that way, is because with that drawing so much current, the other valves wouldn't have got some other current, so the capacitors wouldn't have got as much of a current, so I'm taking the risk. Now the sound is a bit louder. We still have rumble though. It's not crackling like it did before though, so that may have been crackling from in there, but right. Well, it's a start. Here we are switched on. Shall we see which capacitor is going to let go first? That resistor there is getting really hot. Look, you can see it's glistening or something, and it is right below that capacitor. Is that thing dripping? Or is that thing just getting really hot? Oh yeah, that baby is. Oof. Let me do the stupid thing and touch it again. Yeah, that is red hot. That is approaching soldering iron hot. You can actually see how hot it was by the fact that it's actually melted my nitrile gloves. I think that resistor that has shown my fingers what it's like to touch the surface of the sun, I think that is this one here, resistor 69. Even though it's in a slightly different place geographically, if you see what I mean. The wiring goes behind there, and that is very close to there, so it kind of makes sense to me that that might be resistor 69. Let's see what it is. Yep, that makes sense. We have a buzzing, a distinct humming in the speaker, which now I put down to that possibly being short circuit, or that secondary. That secondarily, but that is my primary suspect. Well, it's a couple of days later, and this capacitor is not shorted. Just tested it. So that must mean it must be the valve then. I've just realised that valve 12, which is the valve that that barbecued resistor is connected to, is this guy here, sound output valve. Yeah. Oh no, sorry, no it's not. That's, I've just tapped valve 20. Valve 12 is actually this guy here. It's really difficult to get it, but it's, yeah, this guy here. I thought that was a little too small to be a audio output. So that guy there. Sorry, I know that the lighting is really bad. It's just a bit cramped to get to this back bit without having to take out the entire thing and disconnect all this. There it is. That's the valve we're looking at, and it's a 16A5. So what's that valve in the normal valve numbering system? Oh, N154, PL82. Got a fair few of those. I love how it's probably so rare that the only example they had for a valve museum was one that's gone to air. I've changed. Ooh, presumably you heard that. Interesting. So touching that wire. So yeah, I'll probably need to re-examine my work around here. But anyway, I changed the valve. Right, it warmed up okay, and then I saw a little spark inside, like a little flash. So I wish I caught it. But anyway, so yeah, we need to, first of all, I think that there's a capacitor across the audio output transformer which is connected into the anode circuit of that valve. The PL82 I've just put in there. That needs investigating. Right, and also let's double check my work around here. Okay, I've just switched it off and back on again, and now we're perfectly alright. Is that thing bad? I don't know, I guess it could be. Anyway, don't provoke it, eh? Don't provoke it. Hey, that's how things get worse. That's how things break. Anyway, yeah, so the capacitor that I am going to investigate, if I just change back to the service diagram, is that one there, capacitor 56. Where's my cursor? There, this one. I'm going to investigate that one, because if that's short circuit, then that means that there's too much too much from the HT rail, or the B plus as Americans call it, too much HT rail going through that and then through the valve, so the valve will be suffering. So yeah, resistor 72 may also be hot. That will likely also be hot, and that capacitor may well be suffering. Let's get this one checked. Well, capacitor 56 is not shorted. That feels nice and cool. So, might well be leaky, but even then if it was leaky it would be warm. It wouldn't be cool. Capacitor 57 is okay, we already know that. It's not shorted anyway, and it's not getting hot or warm. Capacitor 58, we have not checked that. Of course, it's probably going to be the last capacitor that we check, isn't it? If it's not that, and something is shorted, then I would say either 75 or 76, which form part of, let me just get back up, which form part of that thing there. Yeah, we need to do some further diagnostics. I'm going to start measuring voltages here. I probably should have done that in the first place. I'm going to measure what the cathode voltage is. It's probably going to be way off what it should be. And the capacitor 58 is this gold one here. That one. Let me switch the light off. In fact, it was even better with the light on, unusually, wasn't it? So that one there, let me just see if I can get my camera to refocus. There. That one. And of course, the next suspect would have to be, which is up there. It would have to be in the most inaccessible part of the set, wouldn't it? Yeah, I think we need to start taking voltages rather than feeling that. I'd be interested to feel it switched on anyway, but let me see if I can show you. That's really quite crusty, actually. And stuff's leaked. Okay, it looks like stuff has leaked out. See from this end how there's like a white dusting on the top of it. I can't really point to it. Yeah, that looks suspect. About the other end of it, the other end. That capacitor is very suspect, as at the cathode of valve 12, pin 3, we are meant to have 11 volts. I like how they mentioned the I'm going to do it a third time. I like how they mention the cathode, the currents as well, alongside the voltages. So yeah, and when I measure pin 3, which is there, it measures a big fat 0. Yep. That gold capacitor that I'm pointing to there, yeah, that's very suspect. Right, so I was getting the chassis out so I could replace that capacitor, and in order to get the whole chassis out, you have to pull the anode cap off the tube, and this thing is so malleated and that it's actually stuck, that the rubber cup has actually stuck itself and is falling apart, stuck itself to the face of the tube and is falling apart. Oh, come on, get off, you bastard. Come on. Ugh. Give me a few minutes. Actually, if I unscrew the metal chassis from this wooden base, that should then allow me to slide the wooden base back in and leave the metal chassis out, so that I won't have this in my way when trying to change that gold capacitor. Okay, so I've got it out as far as I can be bothered. To get it out even further involves unscrewing that, and that is pretty rusty. But I've got it out as far as I can be bothered, and I think I am okay with this. It's going to be a bit of a squeeze getting to that side of the capacitor with the soldering iron. But this side will be easy. Now, all I need to do, because this is just a resurrection, I'm not restoring this, all I need to do is just bridge another capacitor across that. So yeah, I'm not going to take that out. Well, I suppose what I mean is that I'll be disconnecting one end, which will be either end, doesn't matter, and then connecting them to the new capacitor. That's what I mean. But I think we can actually see what has happened. So the capacitor has crapped itself, and some of the electrolyte has leaked out of it and then downwards, or it's leaked something and then the vapour has spread downwards. Some kind of vapour spread downwards anyway. Yeah. Let's chop that end off. I'm just going to chop it out and then solder it to a new capacitor, and then solder the other end of the capacitor to this end here. That thing is definitely short circuit. Where are you? There you are. See, look, it comes down that wire and then to the other probe of my meter. Complete short circuit across that. It's as if it was just a piece of wire rather than a capacitor. Totally short. Okay, minor mistake, for which I do not blame myself. What was that? Anyway, minor mistake for which I do not blame myself. You would think that G1 is for pin 2 and C and G3, which is cathode and G3, grid 3, is on pin 3, wouldn't you? See, 1, 2, 3, 4, 5, 6, 7, 8, and so on. But actually, if you look at that, if I can find it, there we are, and bring the light around, there's nothing connected to pin 2. It looks as though there was at some point, but now everything's connected to... Sorry, there's nothing connected to pin 3. It looks like there was at some point, but now it's just connected to pin 2. Let me see what's going on with this. I need to compare valves. 16A5 versus the PL82, whatever this is. I need to compare that. Right, because the soldering on pin 2 does not look original. This gets even weirder. Unless I'm seeing things. Pin 2. Oh no, sorry, this is me. This is me being blind. This is me. This is the reason why I need to wear Specsavers. I need to go to Specsavers. Well, I already wear glasses. Pin 3, as you can see, has got a wire going to it. Poor lighting made it look as though the wire that is actually going to pin 3 looked like it was just going to pin 2. Okay. Right, I have got both the resistor and the lead to that big fat piece of wire, pretty much. A big fat golden piece of wire. I've got them both disconnected because that resistor and this big one, which was the one that was sweltering, yeah, because that one's in parallel and that one, I both want to test those in case they've suffered. Because if they have, there's no point me connecting up a new capacitor only to solder it up, only to desolder it to remove the resistor. I may as well test the resistor while it's out of circuit. Right, sit rep regarding resistors. That one is supposed to measure 270 ohms. I nearly said 270k there. 270 ohms. It's slightly high, out of tolerance at 322. I am split 50-50 on whether to replace it. Probably will, I think. I mean, not actually take this one out, I'll just leave that paired up with that capacitor and then just put one of my own intact alongside the temporary replacement capacitor. That one I have not measured yet. So, let me zoom the wrong way. Right, let me grab that, put that up. Where's the other end of that thing? Ah, there we are. Put that up there. Let's get that on. Let's get it on. Don't know the rest of that song, can't remember it, but almost impossible to do this with one hand. If you are a one-handed TV repair engineer out there, full marks to you, because this is bloody hard to do with one hand. Right, and let's get the red lead connected to there. And out of the corner of my eye, I see twitching on the meter, 378. Orange, white, brown, with 10% tolerance. Alright, so yeah, sorry, I just got interrupted. Yeah, we've got that on there. Put that on there. And out of the corner of my eye, I see the meter, the digits on the meter moving. 378 ohms. Or if you like, 0.378 kiloohms as that measures, which is the same thing really. Yeah, so that one is actually okay, even though that one was the one that was sweating like a sauna, sweating like a fat man in the sauna. Right, so where are we going to bridge the capacitor across? Well, we can either do it, and the resistor, we can either do it at that end up there, and unsolder this connection, so that the old capacitor and resistor are completely removed, or I can just unsolder that entire wire from pin 3 there, and then solder the new capacitor and resistor in there. The only difficulty I think with the latter thing will be is the fact that I'm right-handed. I just cannot solder with my left hand at all. I think it's just because my mind just kind of, because I'm right-handed with writing, I think my mind just kind of takes the same basis for that. But yeah, that, see at pin 3 there, the one just above the blue finger, the one with the purple mark on. Yeah, that's going to be a bit difficult to do if I'm doing it right-handed, because this capacitor and resistor combination are both going to be blocking it. See from that side, look, it's going to be a bit tight to put my fat arm through there while holding a soldering iron, whilst trying to avoid melting and damaging that capacitor. So I think it will be easier if I tried to, where are we? There we are. If I tried to desolder it from that end, because apart from me having bad camera skills still, apart from these yellow wires, which are easily bendable out the way, I've got pretty much a clear view. My arm has got pretty much clear access up to there. So let's do that then, shall we? This, if this was clean, would probably be either the ugliest monstrosity you've ever seen or an absolute work of art. Pretty much the chaos theory. Except it's not chaos, it's organised chaos, because they're all designed to connect to each other. Right, I've had a look in my resistor drawer. The only 270 ohm resistors I can find are these ones, which look like they are going to be quite low wattage. That's only like quarter watt. I don't know if that will survive very long in that position, because it's only meant to, yeah, because the current draw through that may be through for that part of the circuit may be too much for this. So if it is not enough, I will then tack that in. I know that that's 50 ohms lower, but it should be close enough, and that is a sugar block resistor, what's nicknamed a sugar block resistor, and that is a whole 5 watts, which will be way more than enough. But the resistance is a bit lower. I've searched through that pile. I don't have any 270s, and I don't even have any 330s. That's the closest. So I'll put that there, and we'll tack that one in first. I'm going to try this because it's right resistance, but I don't know, as I said, I don't know about the current rating. Well, I do know the current rating, but I don't know whether it will survive. So, well, there's my temporary repair, and I have connected in the other resistor, the one that was sweating, and we've still got the same thing from the speaker. So yeah, we need to measure some HT now, we've got to. There we are. So I've connected up that to the point in that circuit that's the HT rail. This side of this resistor is that point there, so that should measure 180 volts. Let's switch on, make sure that I've not disturbed any continuity. No, so we've got continuous connection through the heater valves. Right, so see what voltage we get. Okay, that's well, that's okay. I thought it was going to climb further. 190, shall we say 194 volts. It's climbing a little higher. 195. Yeah, let's call it 196. I want to check how much AC we have there. Okay, 2 or 3 volts AC, not bad. It's probably, that buzzing then is probably because the valve has suffered, and the original valve will have suffered as well. I want to see if this thing starts eating valves. So, it shouldn't do that, but we need to replace that valve again that you can see. Should just about be able to see through there. In fact, before I change the valve, I also want to just check if there is AC here. I know I checked this capacitor if it was short circuit, but that does not mean that there could be other faults with it. And it's pin 9 of that valve, which is grid 2 from that capacitor to middle grid, the screen grid. Right, so yep, and we are looking for 170 volts. Right, but we should not have any AC there. If we get any, that should be DC, 170 volts DC. If we get AC there, then that can be the only suspect. Right, so there's no problems here, at least it seems. We have got 177 volts there with no AC ripple, so that capacitor is doing its job, it seems. Right, so we've got other issues then. I am not sure what is causing that buzzing, unless it's just the fact that the other valve suffered. It's either got to be that, or it may just do that normally when it's at maximum volume with no input. Right, so let's see if this thing will sacrifice a decent PL82. And there is the new PL82. Right, let's do this. I hope I'm not wasting a valve here. The new PL81 has an okay heater, but look at the centre, that's glowing purple. It usually indicates a particularly good vacuum. Either that or we've got problems. So at the anode of the 16A5 PL82 really, that is 163 volts, and that says that it's 165 there, so that's within spec. That resistor 47 may have gone a little bit high, but that's within spec, so yeah, I just suspect it may well be a particularly good vacuum inside the valve. So another shrug of the shoulders. Change of plan actually. I've decided that these valves have probably suffered enough. Let's get the line stage working, because there is not a peep of line whistle out of that thing. Not a whisper. Right, and when I've been checking, that is getting quite hot, almost as hot as, where is it, that one in the middle was getting. That one's getting pretty toasty. To the point where, yep, again, it's starting to burn me just then, so yeah, we've got another issue. That resistor is connected to something that is going leaky. What's the betting that it's this thing? That it's that capacitor? That feels a little bit warm. Or maybe that one. There's someone outside. Okay, yep, I made another boo-boo. That there is not that resistor, of course. Yellow, purple, red, 4.7k. It's that one. There seems to be a change in production. 2.2 or 4.7. It's that one. Right, and it's connected directly to that capacitor, 68. I mean, this could also be internally shorted. If it was, though, I think we'd see something a bit more obvious than just the heater lighting up, but yeah, that is suspect. But first of all, I do just want to make sure that the line stage is working. It sounds like it is not, because there is no sign at all, no sound or anything coming from the line output transformer, nothing. Right, so yeah, let's get diagnosing. We should have a minus voltage on on the control grid, which is pin 1. Okay, we're on minus 35, a little bit more in the minus than I would have thought, but I will not complain about that. And it says that here, where this sweaty resistor is connecting. Sorry, the white balance is still setting itself up on the camera, but where this is connecting, that should be around 140 volts. We only have 100. So yeah, I would say that capacitor is leaky. Lazy repair? I'm not at all sure what you mean. Anyway, I've decided not to check that resistor that was getting quite warm, getting toasty, just because it's now 10:15 and my body is starting to shut down. Let's just see if we can get anything out of this. So, power on. We just make sure that we've got heater continuity, which of course we have not. Stand by. I forgot to plug that in, of course. There we are. So now let's see what we get. Yep, we have heater continuity. So now, let's see what we get here. First light. Come on, let's get first light. Itchy foot tonight. Still the buzz on there. That thing is frozen solid, pretty much. Still nothing. Okay, we have an issue. Could well be. Oh, I hear very, very faint line whistle now. I heard it just then. It's that one. We made slow steps. Scratch my beard. But I hear it. It's got no influence from that though. Could be that the valve has already suffered. Yeah, we're going to have to take some voltage readings still. Because remember, we know that the oscillator's running because of the minus voltage at minus 35. So we know that that's okay. Actually, when I test that capacitor, you know when we had 100 volts when we're supposed to have 140, I've now replaced it, we get 97, virtually the same. I will bet that that valve is bad, PL81 line output valve. Right, well, we can definitely check by substitution because I've got loads of those. Okay, that thing is actually so hot that I can't touch it at the moment. I'll need to let that cool down for a few minutes. But yeah, it should not get that hot. It should get hot, but not that hot so that you can't keep hold of it. At least. Ooh. Oh yeah. That is burning. 21A6. At first I thought that this was another PY81. Right, because PY81 usually paired with a PL81, which has the white plastic things, white plastic insulators. But no, 21A6. 21A6 is the Cossor implementation of the design that is also type PL81. Well, why not call it a PL81 then? Here we are, that is a PL81. Notice the white slats down each side. Those are some kind of insulator. Yeah, actually I want to monitor the voltage there. Okay, the valve is just warming up. Let's give it a minute because at the moment, while it's warming up, the voltage readings are meaningless. We want to see what it's like when it's been fully. We want to see what that's like when it's fully untangled, but we want to see what this is like when it's fully warmed up. Right. $79. It still says that should be 140. That's going lower and lower. We've got a fault on the output, I bet. We've got nothing on the anode. I've just tried testing with this. Yeah, I knew that there was a risk to that if there were voltage pulses there, but we have got nothing on the anode of the PY81. Absolutely nothing. I need to test what capacitor 71 says, what the boost voltage across that says, because that, if I can find the line output part of the circuit, no, yes, that is our boost capacitor. Now let me just go on to the next page. There we are, that's the boost capacitor. That should have about 400, maybe 500 volts on this side, which is represented by these green wires here, because the green wires go under the chassis and out here towards the, or one of them goes to the boost diode. Sorry, it doesn't go into the boost diode, sorry. It goes into this. And also, I believe, feeds the tube and it goes off to the next page. It feeds somewhere into the tube, I believe. It feeds the first anode. First anode, I think that's the wrong kind of tube, that's for the 17 inch. That's what we're after, 14 inch. 141K. Yeah. Yes, it does. See, capacitor 71 goes through that resistor, makes a boost voltage here. That would actually explain why our frame stage isn't working either. I don't hear the buzzing because, see, there's the height, so that's the frame stage, some of that. At least that's going to be the frame stage. So it feeds the frame stage, but also feeds anode 1, the first anode of the picture tube. So we need to measure that voltage there. Now normally, and I find this surprising for Cossor, they would give the boost voltage. Oh, they have already anyway. It says the anode, I remember it saying on here, anode 1 400 volts. Yeah, so yeah, there's no resistors there, so yeah, boost voltage is 400 volts. After that resistor there, so yeah, that could have failed, so we don't get enough voltage here. That's the most likely cause. That could have gone open circuit or high, meaning that we get lower voltage there. So yeah, we need to trace this. Okay, so on the green side, top side of that capacitor, we have 186. The bottom, we actually have a minus 2 to 3 volts. We actually have a minus there. Something is not right. And we have no boost voltage at all. So on this side of this capacitor we have 185 volts, which, given that the HT is 180, is about normal. This side we have got nothing. We're supposed to have 400 volts that feeds there. Who thinks that that is open? Who thinks that is totally open circuit? That is this here. Okay, so we have this on the capacitor tester. Let me so we are looking for an eye opening here. Don't know how well it's actually going to show up on there. Oh, we do have an eye opening there. Let me just turn it onto the next scale. Let's see, we have it at about 0.7 microfarads, which is a bit off. What does leakage say? Oh yeah. Oh yeah. And it's only on 3 volts. That is leaky. Same on there. I'm going to put it on electrolytic. The eye stops opening at 150 volts. Yeah, it's not open circuit, it's leaky. There's the new capacitor, a 474, which is 0.47, which is close to 500 to 0.5. Let's see what we get now. Have we still got continuity? Yes. Right. Probably not going to get anything knowing my luck, but right, this thing usually starts conducting at about 110 watts. So the valves are now starting to emit. Starting to conduct, I mean. Some of that sound is just sound coming from upstairs. And we still have diddly squat. I'm beginning to suspect the light output transformer. I'm probably a bit quick to judge that, but that's what I'm beginning to suspect. Oh. Don't know if you can hear that. I heard it earlier, it's a little bit louder, not much. I can hear the line output transformer. Seems to be coming out through the speaker. Have a listen. Don't know if you can hear that, but it's definitely coming from the speaker. That should be coming from there, not over there.